Hi everyone. In the given problem statement, we have to search our 2D matrix. We are given an m cross n integer matrix with the following two properties. Each row is sorted in a non-descending order and the first integer of each row is greater than the last integer of the previous row. These two statements are going to be very crucial for us to able to solve the problem. Now we are given an integer target. We have to return tree if target exists in the matrix or false otherwise. You must write a solution with big O of log m cross n time complexity. Now we know, right? Whenever we are talking about log time complexity, right? The best way of searching or the only way of searching is going to be binary search. But the problem out here, right? Instead of a linear sorted array, this is a 2D matrix. How are we going to solve the problem? So the first thing that we need to understand, we have to use these two statements. Each row is sorted in a non-decreasing order. And the last integer of each row is greater than the last integer of the previous row. Let us take this example out here. The target is 3. Okay. Out here we can say, let's say out here, right, the top right now is 0 and the bottom is 2. So this is the topmost row, which is 1, and this is the bottom row, which is 2. Sorry, this will be 0. So I can find the mid out of it, right? So mid would be 0 plus 2, like when we do the binary search divided by 2. So our mid would be 1. Now I am at the 1 position. Now here I know the smallest available element in this entire mid row, right, is 10, basically the smallest one. Now the question is 3 smaller than the current 10? Which is true, the 3 is smaller than that. So I can do one thing. I can, let's say my bottom value would become now 1 minus 1, basically mid minus 1. So it would be 1 minus 1 and our bottom value would be 0 right now. Now the question is 3 smaller than the last element which is present out here? Which is not 3, not correct, right? 3 is greater than that. And also a question might arise, is 3 greater than 7? Which is not true. 3 is smaller than 7. So we are for sure, we are certain that the answer is going to be lying on the first row or the 0th row. Now once we got this right, so we can do a basic binary search on this elements. So our basic binary search would be like, we already know, right, the basic binary search. So here I can say our left would be 0 and right would be, in this case, right would be 3, and our mid right is going to be 0 plus 3 double divided by 2, which would be around 1. And I can say while L less than equal to R, and mid is basically L plus R double divided by 2 if, and here, right, we find the value of the row, right? So row would be 0. So if our matrix of row of mid, okay, if it's less than the target, then in that case, right, we can say L equal to mid plus 1, L if matrix of row and mid is greater than the target, if it's less than the target, I think it would become, it would be R equal to mid minus 1. and in this case it would be L mid plus 1. And in the else case, right, we are basically found the element, so we can return true. Or if the while loop exists, right, and it's still not able to find any element which is forming that values, so you can simply say return false. So that would be the idea of this program, and it's a very simple problem because you have to use binary search, but instead of normal binary search we have to use two-way binary search out here, so which would be very very important out here. Now let us jump to the Python solution. Hi, the first thing that we are going to do, right, we are going to calculate our topmost row, which is going to be 0, top and bottom row, so which is going to be 0 and the length of the matrix. Now we are going to do few more things. So basically we are going to say while top is less than equal to bottom. So if that is true, right, so here the most important part, we are going to calculate the row which is going to be top plus bottom double divided by 2 to get the mid of it. Now you're going to check if matrix of row of the 0, if it's smaller, or let's say if it's greater than the current target, in that case what we have to do, we have to decrease our bottom equal to row minus 1 elif matrix of row of minus 1, the last value in the matrix in a particular row, right? If it's smaller than our target, then we can say we can keep on increasing our topmost value, means you're going to come down, our search value is going to come down. So it would be row plus 1. Else we are basically going to just break because we have found the row where most likelihood of our target element to be found. Now once we have done that, right, we are going to check in case if the bounding, right, the top should always be less than bottom. So if in case during this operation, right, the top has increased than our bottom, then we can say, right, the validity has been broken and we can return false. So the likelihood of that element to be found is not possible out there. So false. Now we can do the left and right. So left would be 0 and right would be length of matrix of 0 or any element we like. So while L is less than or equal to R, we're going to find the mid. So mid would be L plus R double divided by 2. And now we're going to check if matrix of row and mid is greater than the target. Then we can shift our mid, or shift our, let's say it's smaller than the target for the first instance, right? If it's smaller than the target, right, so we can say L equal to mid plus 1 elif matrix of row and mid is greater than the target, then r equal to med minus 1, else we would basically mean that we have found our element, so we can say return true. And in case this loop also exists, right, or this loop worked out fine and we are still not able to find an element, that basically means that element does not exist in this current matrix, so we are going to return false in that case. Now if I run this code, ideally it should work. Let me see. As you could see, the public test case is passed. Let me submit the code. And the mistake I made, right, was when I'm calculating the length of matrix set, it should be -1. So it's a very silly kind of a mistake. Let me run it back. And ideally it should work. So it is working fine. Let me submit the code. As you could see, all the test cases passed and it is giving a runtime of 100%. So it's very smooth. And if I look into the time complexity of it, right, it's going to be big O of log m cross n. There are 2 times you're doing a binary search and it's pretty efficient, the code from the looks of it. That's all for this video. See you in the next one.